The next speaker is Delsing, and he is representing the third pyramid of ERIC, which is the AIPP, which is a young phenomenon. So the project is coming on stream. Results might be very preliminary, but we thought it would be interesting for you to hear the approach they are taking, because we hope that for the new call, which is going on right now, the project proposals can learn from what Jarmo Delsing is going to tell you.
Thank you. About Arrowhead and what was the drivers behind and where we are right now. And Arrowhead was created with the support of one of the Center for Innovation Excellences, Process ITU. And we took a focus on process and energy system automation. And I'm going to try to walk you through some of the thoughts that have been during this journey and where we are currently. Some background, we all know these society challenges on energy, water, environment, and we also, many share that increased automation is a tool to actually address these. Addressing automation and this type of topic has been done, but this type of technologies, this is an ISO 95 approach to an automation system for a larger plant. In this case, it's actually taken from a pelletization plant up in northern Sweden, in the AIPP mining company. Although such installations can be big, we're talking about tens of thousands of hours and sensors and actuators involved in the optimization of this type of systems. Many Artemis, for sure, and companies like Ericsson are predicting numbers which are order of magnitude much bigger in connected devices. Ericsson came out 1.5 years ago with 50 billion, Artemis are talking about 40 billion, others are talking about roughly the same numbers. If it's 10 or 100 billion, doesn't matter. But the conclusion is that can we use ISO 95 approaches to connect all these devices? And basically, that will require more engineers than we have in the world. We don't even have that many people in the world to handle it. And that means we need to move to another paradigm of thinking around how we build automation systems. And this is kind of the driving forces behind where we are living. The understanding of this has been seen by a number of projects previously, made both in Artemis and by the FP7 and Artea. A number of them are listed in the top blue box there, and also a number of end users. A number of the AIPPs who are organizing end users in Europe have seen the same thing. And end users are looking forward to something which I call collaborative automation. And this is some of the stepping stones that we are trying to use in Arrowhead. So the approach is based on words like this: TCP/IP everywhere, middleware nowhere, Internet of Things, service-oriented architecture, system of systems. And this has led to a vision for the enabling collaborative automation by network embedded devices, and identifying two grand challenges. And the first one is enabling interoperability of services provided by almost any devices. Means that the belief is that services provided by devices will be a route to go, and that services from device A and supplier A should be able to interoperate with devices and services from any other supplier as well. And the second challenge is that these should be integrable to create a system, an automation system, and that this integration should be possible to be supported by machines. Lead being the step of enabling handling 50 billions or whatever number of billions of devices to look forward to the future. It's a big undertaking, I understand that, but anyhow, there is today 77 partners forming a team to address the issue and also demonstrate this into the future. Just to explain what has happened in some of the projects, this is, I hope, the only technical slide I'm going to give. Many of the projects we've seen have started to use service-oriented protocols, and this is just 5, 6 of them right now. There are at least 10 that's around, and they are really not compatible, they are not interoperable. If we go higher up in describing the services, I've listed another 5 different versions of things there, but I'm sure there are at least 300 different versions. How to, for example, explain temperature or describe temperature as a service. And the problem is that none of those are already standardized. So it's an interesting challenge. Anyhow, all this has inspired and taken a number of partners together. 77 partners from not every country in Europe, but the map is covering quite a large portion of Europe. We didn't reach the size that Eric was envisaging. A number of reasons behind that, but we did a fair try to move to that volume. This is what we're going to work with. Building clouds around applications, enabling the automation cloud, tying in interoperability and integrability. We're going to demonstrate this in 5 different domains, and this is my little kind of baby sketch on putting these together. It was made one night, very late, and it's still alive. It's used by quite many people right now, so I'm hanging on to it. But we're talking about production, both manufacturing and process production. We are talking about energy. We are talking about smart cities. We are talking about automotive, and around all this, a market connecting information. What we're looking forward to in this case is information related to energy. And it could be described in this way as well. Efficient production, smart buildings, energy production, electromobility, and a virtual market of energy. The ambition is to demonstrate the usage of this type of interoperable service technology within these clouds and, in particular, in the communication to a market. There are some things around technology foundations. We are looking forward to develop and investigate an Arrowhead service framework, handling information infrastructure, information assurance, and system management. We are looking forward to integration to and migration of these systems. And we will also provide a virtual test bed to which people can
test services whether they are interoperable and hopefully also integrable to a larger system. And this is just a picture of the same plane. There are three basic components: integration to legacy systems, which we think is a very important thing, since all those legacy systems are already there and they're going to be there for quite some time into the future. And taking the automation system I showed in my first slide, which grid-based sketch like this, we are looking forward to have a cloud implementation of this, not only for a single process automation system, but for all these applications that we are looking forward to, and the integration between areas as well. These are going to be demonstrated in great world environments in cooperation with end customers, and aiming to prove technology feasibility to the marketplace. We're going to show this in 10 different areas within production. I will not go through all this, but one of the examples is from the airline industry, where we are looking forward to airline maintenance information, and that's going to be communicated and shared between airline suppliers, airlines, and maintenance companies, and how we can build such a structure. Going to be applying to smart buildings, looking into energy efficiency, eco-sufficient homes, and things like urban lighting, and how we can build control rooms supporting these type of optimizations. Looking into electromobility regarding charging of upcoming energy, mobile energy supply or usury. They're going to pay both. At least that's what people will say. Energy protection, how we connect end user needs in real time with how we actually produce energy in real time. And that can be optimized. And all this will then also be connected in different ways to an energy market that a number of our Danish partners are supplying and going to integrate into this scenario. To actually bring this to the market, a number of partners have identified key innovation enabling technologies, where we are looking to say, if this is not there, this will not fly. And that's around security, things around energy harvesting when devices are located in places where they're built in forever. For example, a thing like this, which is a bearing, but that's one built into a regular wagon. It's going to sit there until it breaks down. We need energy harvesting around these type of devices. We also need them to have capability to communicate, for example, through steam. And we are also investigating embedded system business, embedded service business models. How would that look like? Can, for example, SKF, who is a supplier of such a bearing, sell the information, the maintenance information? And it can be built a business model around that. That will work together with this virtual market that was talking about a minute ago. This can bring us to situations where we have information in the bearing that sits here, and when something happens there are a number of stakeholders that are actually interested in that information, and that we can engineer the supply, the trade of this information to all these stakeholders what it's built to machines, not how the engineers to actually rely on code for them. And that's hopefully give you an idea of what we are trying to put together. You see what I'm right now proposing as the dollar for this. I think I've lost the Artemis symbol here and there, but I apologize for that. We certainly want and we'd like to be part of the Artemis community. And right now there is a draft website. In 1 or 2 weeks the draft's going to go away and you're just going to find us at arrowhead.eu. And someone that